ESS, Atmospheric Systems and Pollution Management, Part 9, is focused on strategies for mitigating the impact of solid domestic waste using the framework for pollution management. I've introduced this framework previously. I've attached solid domestic waste, which is part of Topic 8, to Topic 6, Atmosphere, because it nicely fits within a pollution topic. The significant ideas are solid domestic waste is increasing as a result of growing human populations and consumption. Both the production and management of solid domestic waste can have significant influence on sustainability. And lastly, pollution management strategies can be applied at different levels. This slide provides an outline of all the movies available for the Unit on Atmospheric Systems and Pollution Management. Use this slide to find the movie you need for review. This movie is focused here on strategies to mitigate solid domestic waste. Here are the major categories of pollution: combustion of fossil fuels, industrial and domestic waste, solid domestic waste, manufacturing pollution, toxins and CFCs by way of example, and agricultural pollution in the form of fertilizers and runoff and pesticides. This movie focuses on solid domestic waste. Here is the framework for pollution management. You should be familiar with the framework at this point in the course. You should be able to describe each of the 3 levels of mitigation. Strategy 1 is altering human activity by promoting the development of alternative technologies or alternative lifestyles through campaigns, education, government legislation, and economic incentives. Strategy 2 is controlling the release of the pollutant by legislating and regulating standards or simply removing the pollutant from the point at which the pollutant is released to the environment. And lastly, strategy 3 is cleanup and restoration of damaged ecosystems. Here are statements that are found directly in the IB syllabus that relate to each of the 3 strategies of pollution management. In the first strategy, the syllabus indicates altering human activity, for example, through a reduction of consumption and composting of food waste. For strategy 2, the syllabus says controlling the release of pollutant, governments create legislation to encourage recycling and reuse initiatives and impose taxes for solid waste collection and taxes on disposable items. And for strategy 3, the syllabus statements are reclaiming landfills, using solid domestic waste for waste-to-energy programs, and implementing initiatives to remove plastics from the Great Pacific Garbage Patch, which is a cleanup and restoration activity. And as we move through pollution management with respect to solid domestic waste, keep in mind that strategies for solid domestic waste management are influenced by culture, economics, technology, and politics. These factors could be barriers to the proper management of solid domestic waste. And remember that the most preferred strategy for pollution management is the first strategy, alternative technologies or altering human behavior that results in source reduction or reuse of materials. Treatment of waste or cleanup or restoration programs are expensive, and damage to the environment has already occurred. Strategy 1, altering human activity by promoting alternative technologies or adopting alternative lifestyles, would include reduced consumption, as seen in all of these images. To reduce solid domestic waste, it's easy. Buy less, reduce consumption, reduce shopping to reduce solid domestic waste. Reduce is a strategy included in the first level of the pollution management framework, altering human activity by promoting alternative technologies or adopting alternative lifestyles through campaigns, through education, government legislation, or economic incentives. Now, this image focuses on e-waste, electronic waste. Reduce solid waste by buying less. Reuse and recycling fall within the second strategy of pollution management framework. But by reusing or recycling, less material is needed to be processed in the first place. So, reuse and recycling fall under Strategy 2 and Strategy 1. Composting food waste serves to reduce solid domestic waste. Food waste or other organic matter, such as leaves, are broken down by bacteria within controlled conditions. The remaining inorganic molecules, as dark, rich material, are added to the soil to help grow crops. In composts, organic matter, leaves, and food waste are broken down in short periods of time into inorganic molecules by bacteria and fungi. Compost is a key ingredient in organic farming. Composting reduces solid domestic waste. Here we can see a community effort in composting. Now let's look at the second strategy in pollution management. Strategy 2, controlling the release of the pollutant. Governments create legislation to encourage recycling and reuse initiatives and impose taxes for solid domestic waste collection and taxes on disposable items. Reuse and recycling serve both of the first two strategies in the pollution management framework. While removing the pollutant from the waste stream is the second strategy, when we reuse or recycle, we also reduce the need for more materials in the first place. In other words, if we recycle aluminum, Strategy 2, we need less aluminum to be mined from the earth, Strategy 1. But remember, management strategies for solid domestic waste are influenced by culture, economics, technology, and politics. If societies do not nurture the culture of recycling, recycling is less likely to happen. So let's be clear. Recycling is defined as collecting and separating waste and reprocessing the materials for use or reuse. But remember, management strategies for solid domestic waste are influenced by culture, economics, technology, and politics. If a society does not have the technology to recycle, the technology you can see in this image, the lack of technology can be a barrier to recycling. Recycling would be less likely to happen in that case. Reuse is defined as the separation of waste without processing, and then reusing. But remember, management strategies for solid domestic waste are influenced by culture, economics, technology, and politics. If a society does not have the technology to reuse, the lack of technology can be a barrier to reuse, and reuse would be less likely to happen. This image shows people in a less economically developed country recycling and reusing e-waste, wires specifically. Management strategies for solid domestic waste are influenced by economics. Markets for materials drive the reuse and recycling. Here is an example of the intersection of culture, technology, and economics in recycling and reuse. The use of recycled plastic to make bricks used to construct homes. Does a society have the technology to do this? Does a society have an economic market for the plastic bricks? Do you want your home constructed of plastic bricks? Culture, technology, and economics influence the management strategies for solid domestic waste. In this image, technology is not a barrier. But does a society have a market for plastic bottles for the purposes of building walls? Would you like the walls surrounding your home to be made of plastic bottles? Culture and economics influence management strategies for solid domestic waste. Have you heard of upcycling? Upcycling is creative reuse. Upcycling is the process of transforming waste materials into new materials of better quality or for better environmental value. Roads made of recycled rubber, earrings made from bottle caps, the soles of shoes made from tires, and shopping bags made of recycled plastic. All of these strategies reduce solid domestic waste. Do we have the culture to accept upcycling? In these images on this slide, we see classic reuse as a strategy because no reprocessing is required. The empty plastic bottle provides light when filled with water and inserted into the metal roof. Light, of course, when the sun is shining. Management strategies for solid domestic waste are influenced by politics. Governments create legislation to encourage recycling and reuse initiatives, and governments impose taxes for solid domestic waste collection, as you can see in this image, and taxes on disposable items. Management strategies for solid domestic waste are influenced by politics. Governments create legislation to encourage recycling and reuse initiatives, and they can impose taxes for solid domestic waste collection and taxes on disposable items. You can see in this pie chart that solid domestic waste could be reduced to 20% of what households now throw away. All of this is compostable, and all of this is recyclable. Remember, we're following this framework for pollution management. Humans produce the pollutant, we release the pollutant, and then the pollutant has impact. When I refer to strategy 1, I'm referring to this level of management, altering human activity by promoting alternative technologies or the adoption of alternative lifestyles. Strategy 2 is this level of management, controlling the release of the pollutant. And strategy 3 is this level of management, cleanup and restoration of damaged ecosystems. And I'm also working my way through these statements that emerge from Topic 8, Management of Solid Domestic Waste. I've covered Strategy 1, where we've looked at the alteration of human activity, for example, through reducing consumption and composting food waste. We've looked at Strategy 2, Controlling the Release of the Pollutant, where governments create legislation to encourage recycling and reuse initiatives, and governments impose taxes for the collection of solid domestic waste and taxes on disposable items. Now on to Strategy 3. We will look at landfills. We will look at using solid domestic waste for waste-to-energy programs. We will look at implementing initiatives to remove plastics from the Great Pacific Garbage Patch. This is a cleanup and restoration activity. Burning waste or incinerating waste, as you can see in this image, is a level 3 pollution management strategy in the sense that incineration extracts and removes the pollutant from the environment. By burning domestic waste, energy is produced and can be used, waste to energy. But incineration is expensive, and there's a possibility for the release of toxic gases. Incinerating domestic waste not only removes the waste from the environment, but it potentially produces energy that could be used locally. Waste to energy. But incineration is expensive, and there is a possibility for the release of toxic gases depending on what's being burned. Consider the costs of incineration, and consider the benefits. Energy production, waste to energy. Consider the politics involved with building an incineration facility. Nobody wants an incineration plant in the vicinity of their home. Consider the technology involved with incineration. Consider how culture, economics, technology, and politics intersect in pollution management. A landfill is the place to which solid domestic waste is sent and buried. Governments are involved with the creation of landfills, and they set the regulations that mandate landfill use by individuals. Landfills require high technology to avoid having toxic compounds leak into the groundwater beneath a landfill. Landfills are complex structures of high technology, including liners to prevent toxic compounds from leaking into groundwater. As well, landfills have the technology to extract methane that could be used to supply local energy. Landfills also have a finite lifetime. In other words, once they're full, a new location must be found. Remember, landfills require high technology to prevent toxic compounds from leaking into local groundwater, and high technology to extract the methane that could be used to provide some local energy. Consider the costs of building a landfill. Consider the technology to prevent toxic compounds from leaking into the local groundwater. Consider the location where landfills are constructed. Consider the politics of building a landfill because nobody wants a landfill located near to their home. And what happens when a landfill is full? Here's an image of a former landfill underneath the ground on the hill in the left of the image. There are pipes to extract the methane for local energy use. Here is a landfill at the end of its life. A grassy cap covers over the waste that lies beneath. Think about all the nasty stuff that is in this landfill. Hopefully the liner holds up over time. Methane can be extracted and burned for local power. So now let's look at initiatives to remove plastics from the Great Pacific Garbage Patch, which is a cleanup and restoration activity. Can we effectively remove plastic from the ocean using booms, as you can see in this image, that skim the water? Consider plastics that have gone to the bottom already, and it's expensive, and it doesn't cover a lot of area, given the huge surface area of the ocean. And, of greater importance, the environmental damage has already been done. In these images, you can see technology to filter ocean water in an attempt to remove plastic from the ocean. Consider the cost. Consider how effective this strategy might be, given the vast scope of the ocean. Here is a device designed by a teenager from the Netherlands to clean the oceans. Consider how technology, economics, and politics might intersect to influence pollution management. While this outline from Topic 8 of the IB ESS syllabus does cover incineration, landfills, and the cleaning up of the Great Pacific Garbage Patch, I can't leave this movie without mentioning the obvious. Simply cleaning up the pollutant and allowing ecosystems to recover is a strategy of pollution management. This strategy is not nearly as good as Strategy 1 because damage to the ecosystem has already been done. So here's the inherent problem with Strategy 3. Environmental damage has already been done. Strategy 3 is cleanup and restoration of ecosystems. Consider the costs. Consider the need to repeat the cleanup year after year. Consider the environmental damage already done. Remember, I've been following this framework for pollution management throughout this movie. You need to study this slide on your own. And that brings us to the end of IB ESS, Atmospheric Systems and Pollution Management, Part 9.